Recording in progress. I guess we're recording. All right. So let's go. So hello, everyone. Welcome to my channel. This is going to be another kind of video, not my typical technical content. I have a special guest here. I'm here with Elvin Arias. Am I saying it that correctly? By the way, I forgot to ask that. Yeah,
it's correct.
Okay, perfect. Cool. So a quick introduction for anyone who doesn't know. Elvin is not only a wonderful friend, but also a multi-talented network expert. He has 2 CCIEs. He's worked with Cisco and now with Amazon, and he has a lot of experience, and he is really good with all networking related stuff. So he's going to help us with this video. Before I throw the ball at him, I'm just gonna describe the scenario, what we're doing here. So we're actually answering a question from Cisco Learning Network regarding OSPF. I have drawn the scenario here and I'm gonna explain it shortly. I'll just show you the question itself really quickly here. I'll leave a link in the description so you can have a look at this yourself. So it's the whole thread is pretty long, so I'm just going to try to summarize it. So let me go back to the diagram here. So the topology consists of 4 routers connected in a chain like this, and I've included the exact IP addressing and interfaces that were used in the scenario. You can see the configuration for each of the routers in these boxes. And if you're wondering what this highlighted, or sorry, not highlighted, the red text here means, is this is something I've changed from the configuration in my own lab. So router 1 is going to have the router ID of 1111, because originally it was actually assigned to router 3, but I feel like it's a bit more clear if it's on router 1. So let me just show you that real quick here. R3, it had the router ID of 1111. So that's what that means. And then if we look at these boxes, so what the question is, so area 2 is configured as not so stubby area. And when it's configured like that, we can see both of these routes in the routing table. So there are 2 external routes advertised from R3, which is an ASBR. If you can see here is the default information originate command. So it's advertising the default route. And right now it's present in the routing table on R2. But now if we configure R2 as a totally NSSA, so we add this no summary on the command, it disappears from the routing table. So that was the question, like, why does it happen? Why is the default route no longer in the routing table of R2? And by the way, R3 and R4, they are not running OSPF, but the default route and actually this other static route from R3 are pointing towards R4. So that is the scenario. Did I miss anything, or did I misspeak anything? Elvin, did you catch anything, or is that about it?
Yeah, that's basically what it is. The question is regarding what is the actual mechanism besides as to why, also what is the mechanism in which the ABR or whatever the router in transit uses in order to invalidate, or how does it invalidate the prefix, right, going into the backbone, the default route. So okay. We will see that in the video.
Yeah, so I'm gonna let you share your screen. You have this scenario in your lab topology. I believe you use slightly different IP addressing, and your virtual environment is set up maybe a bit differently, but it should be easy to follow. So if you want to share any more information about that or show anything, feel free to do that. I'm going to stop sharing now, and then you can take over.
Yep. Sure.
Okay.
Sure. So in this case, let me share my desktop. So in this case, as you see, it's going to be similar topology, if not the same. The only thing that will change is the addressing between router 1 and router 2 is going to be 10.1.2x, where the X is going to be replaced by the router number. So router 1 is going to be that 1, router 2 is going to be that 2, and so on and so forth. And each router is going to have a loopback address assigned that is going to correspond to the router number /32. So it's going to be essentially very easy to follow topology with 4 routers. R1 and R2 are in area 0, R2 and R3 are in area 1. And that's the area that's going to be totally NSSA, or that we are going to put as an NSSA. We are going to see the behavior initially, and then we're going to convert into a totally NSSA and see in action what is the mechanism that iOS uses for this. As you mentioned, R4 is basically a non-OSPF router. It's going to be there in order to be an X hop for the default route that R3 is having in its routing table. So yeah, that's basically it. So to see the topology in action, so we have router 1. As you see, router 1 has three inter-area routes, and one is coming from R3, which is the router that is advertising its own loopback, and also the transit link as well. R2, of course, has 2 peers, R1 and R2, as seen in the topology. R2 has 1 in R3, excuse me. And R3 will only have a single peer towards R2, excuse me. In this case, let me check all the OSPF links. So yeah, so in this case, I haven't converted the areas as an SSA. Everything is as per default, right? So I just configure, if I do show IP OSPF, I will see that these are not special areas. This is the backbone. And in the case of router 2, one is in the backbone and one is in area 1, and it is not in a special area, right? So now we're gonna make it as an NSSA initially. So if I call all the configuration for R2, I will see that everything is as per default. And I'm gonna go into the router OSPF and I say area 1 NSSA. Now, R1 is gonna make area 1 as an NSSA, and I have to do the same in router 3, right? So now, if I ask OSPF, it's gonna say that it's an NSSA area, right? So there are a couple of things that happen here, as you know. One is that it's going to start filtering external prefixes into the NSSA, and another thing that's going to happen is that R3 now is able to generate LSA type 7 due to this, right? So R3 has a default route that we're going to start redistributing. The mechanism of redistribution, as you mentioned in your topology, is going to be with the same command, area 1 NSSA, and we're going to say default-information-originate. One key thing that we have to mention here is that R3 is an internal router inside the NSSA. It's not an ABR. And in order for an NSSA internal router to generate the default route with this command, the default route has to exist in the routing table. If this router was an attached router that was attached to the backbone, it was an ABR, right? It was attached between area 0 and another route and another non-backbone area. It doesn't need the default route in the routing table in order to generate it because it has the border bit set. And as soon as it sees the border bit, it starts to generate the default route into the NSSA. But now in this case, it's generating the default route out towards the backbone and towards any other area. So if we go into the OSPF table, we're gonna see that this router, R3, is generating an NSSA external that is being advertised by itself with the link state ID of 0000, which is the default route. This means that, and also one key thing is that the translation bit is set. So as soon as the ABR will get this advertisement, is going to be able to translate it accordingly. So if we go into the area 1, excuse me, router 2, we're going to see that the default route is there as an NSSA type 2, and that if we ask for the prefix in the database, we will see that the translation is there, still there, And if we go into the internal backbone router, that is R1, we're going to see the default route is there as an external type 2. So in this case, R2 is taking the default route as an NSSA type 2 and is basically translating that external type 7 into an external type 2, into an external type 5, excuse me, as a type 2, E2. So in this case,
Right.
it's basically copying the same thing and just injecting it into the backbone. So up to this point is very simple. So the mechanism here is to simply translate the prefix into the backbone. So for the scenario specifically, up to this point is fine, but let's see what is the behavior if we convert this area into a totally NSSA. Mm-hmm. So what I'm gonna do now is I'm gonna go into router 2 and I'm gonna put the command no summary, area 1 NSSA no summary. So this is gonna make R2 be a totally NSSA, convert this area from NSSA into totally NSSA, while router 3 is still advertising or injecting the default route, and see what happens here. Area 1, NSSA, no summary. In this case, router 2 is gonna do a couple of things, and one of them is that it's gonna be suppressing any external type 3 and external type 5 advertisement into the NSSA, into area 1. And one thing that we're gonna see as a behavior as a result of that is that we will not longer see any default route in router 2. But something that we have to notice as well is that if we check the routing, if we check the OSPF database, router 3 is still advertising the NSSA default. And also, if we check again the default route, the OSPF routes in router 1, which is an internal backbone router, we will not longer see the default route as well. So it seems, based on this behavior, that router 2 is no longer translating the default route coming from R3, which is the internal NSSA router that is still originating the default into the backbone. So if we check the database, as we see that the default route is still there. If we go to router 3 now, we see that there are no SPF routes, right? Because now router 2 is suppressing any type 3, any type 2, excuse me, any type 3, any type 5 advertisement into the NSSA. And now R3 simply just have a default route statically configured, which is the default route that we have. If we check the OSPF database, we will see that router 3 is advertising, is receiving, excuse me, from area 1, a default route coming from router 2, and it is generating locally from itself also a default route. So it's receiving a default route from the backbone, or excuse me, from the ABR, which is router 2, and it's also generating its own local default. But it's not installing either in the routing table because it already has a static route that is a default route. So now we see the behavior in action where R2 is basically not injecting the prefix into the backbone, and this is basically the behavior that was observed in the post. Any questions until now?
Yeah, like I can understand the behavior on R3 and why R3 is not installing the OSPF route, the default route, because it already has the static route configured. But if we go to R2, like I cannot understand why there's no default route installed into the routing table, because it should be learning the route from R3, and then it should be locally generating a default route, the type 3 default route. So I don't understand really what is happening here.
No, because yeah, so the behavior that we are seeing right now is expected because as soon as the ABR of the NSSA generates a default route into the NSSA, it stops translating any other default route coming from the NSSA. So yeah, go ahead.
Can we look at that in the OSPF database again, what that route looks like or what the LSA looks like?
Of course, yes. So let's go from the one who generates the prefix, and then start from then trace it back up to the AVR.
Yeah.
So router one has a local default route pointing to R4. Check how is generating the default. Is generating the default from itself, saying this is the default, and I'm just flooding this LSA as a type 7 into the NSSA. R2 eventually will receive that route, or excuse me, that LSA. It's gonna say, well, you know, I have this LSA as well. OSPF database, it's the same. I have this LSA that is coming from router 3, is being advertised, but the routing bit is not set. If you see, the routing bit into the LSA is not set. And the reason why is that if we check the internal for that route, the internal command, the internal keyword for the command, it will say that the distance is set to the maximum, which means that the LSA is being invalidated. And the reason why is because I am already generating a default route into the NSSA, and the mechanism of invalidation triggers, and now the LSA cannot be translated into the backbone because it has a distance set to the maximum. Because I am already generating a default route locally into the NSSA.
Let me double check something, because I have my own EVE-NG scenario here as well, and I've also included the other static route, the 8888 network, but I'm pretty sure if I look at that with the same command, let me just log in and see so I don't misspeak. Okay, what was the command again? Show IP OSPF database internal something. Let's see, because I'm pretty sure that showed the distance as the same value, but then that route was still being advertised. Let me see. Yeah. So I don't know if you want to try that on your on your topology, or if you want me to share mine, but if you add that route, yeah, from it was like 8.8.8.8.0 and /24 or 255. And yeah, it was pointing to R4. So that was also included there. And there was redistribution. So it was, let me double check that command as well. Redistribute static subnets.
Yeah, I just did it.
Okay. So I think that, at least in my lab topology, on my EVE-NG lab, it's showing up as the maximum distance as well, but yet it's still being advertised to R1.
Yeah, so let's see. Show IP OSPF database, NSSA external. I would see two LSAs now that I'm generating an additional route. And in this case, the route is 888.0, as you mentioned.
Yeah.
If I check the 88880, I see it. If I check the internal, I see that the routing bit is set on this route.
Okay, your output looks different from mine, I think. Let me see.
Yep.
Let me just double check. Yeah, this is different from the output on my lab.
Okay, that's interesting. I would like to
Yeah.
see which version are you using and everything, and because I'm using the 15 something, using 15.2.
Let me see, show version.
This is very old.
I am using 15.6 2T.
Okay, yeah, I can dig into what's the mechanics in that version, but in general, this should be the output that you have to see, right? So you should see that for the normal route, you will receive the route, you will still have the routing bit set into the route because you are translating that route into the NSA, into the backbone, right?
Mhm.
In this case, type 7, type 5 translation is happening. There's no maximum metric set, and the LSA is now being generated locally in the backbone, as you see it right here. So
Right.
I asked for the LSA as an NSSA external in the ABR. It showed me that the routing bit is set and is translating the prefix, as you see here. Routing bit set, and the translation is happening. And if I ask in the same router for the external, is doing the translation already, and is basically being advertised by itself, which is router 2. So as router 2, I am injecting that prefix into the backbone. So this should be the output that you see. In this LSA, of course, it doesn't have the routing bit set because the router already has a better advertisement as a type 7. But if you check in router 1, it has a translation, and it should have, right, 888.0. It should have the routing bit as well. So this should be the mechanism, right?
Right.
Yep.
So can you explain a little bit more about the routing bit as well? I don't know if I remember that in full detail, what the routing bit means.
Oh, the routing bit is simply a mechanism to say that we are using the LSA, that the LSA is being used actively for routing in the LSA. Yeah. So it's basically a local flag in the iOS that it will suggest that this LSA is being actively used for routing, right? So in this case, if you see doing the spot on the comparison in router 2 is basically receiving one LSA inside the NSSA saying, hey, this is being advertised from router 3 internally, and saying this is being advertised from router 3, right? Advertising router is router 3, and I am using the LSA because if I check the routing table for this prefix, which is 888.0, I will see that this prefix is coming from a type 2 NSSA. So this LSA is actively being used, and hence is being installed in the routing table accordingly. But this router is also generating a default, the same prefix as a type 2 external route. And the routing bit is not being set because it's not using the LSA. But other routers inside the backbone are using the LSA, if you see, and hence they are also setting the routing bit. And if I check the routing table says yes. So that's basically the indication of the routing bit in this case.
Okay.
Yeah, that's very useful to map what is being installed in the routing table or not.
And then the internal keyword in the command, like what does that mean?
It means that you basically will show internal information of what is actively being flagged into the LSA to avoid or to allow certain things. For example, if you look at the LSA here for the NSSA, 0000 internal, you will see that, let me see, this is router 2. Yeah, router 2, right, OSPF database. Yeah. In this case, you'll see that the distance is set to maximum. So basically this router locally is flagging the LSA as untranslatable, but we don't see that in the normal output. We don't see the metric that is being set. We see just the metric that is being advertised by our peers. So the internal keyword is basically a flag that will show private information about the LSA. That's how it's called, just private information about the LSA that is locally being flagged in the local device. So in this case, it's basically setting the distance to avoid the translation to invalidate the LSA, to avoid the translation, because as per the OSPF rules, if I am an AVR and I'm already providing you a default route advertisement, I shouldn't be installing the default route from you. Right. And also in this case, the AVR is generating a type 3 LSA, default LSA. and it's overriding any other advertisement coming from router 3, because router 3 is generating a type 7 default route. So everything that router 2 as an ABR is advertising, because it's a type 3 default route, is basically overriding any advertisement coming from the NSSA directly, because the ABR, or excuse me, the ASBR inside the NSSA can never generate a type 3 default route.
Mm-hmm.
Because in order to generate a type 3 default route, it has to be attached into the backbone. It has to be attached to area 0. So hence is overriding the advertisement. So another key thing that you can use is this. So if you show the debugging, I activated the debug IP OSPF SPF, right? So if we roll back the command again, let's see, in order to see the activity of the default advertisement, let's see, no area 1, say, sorry. See, I remove the command. Let's see how it is right now.
Mm-hmm.
Right now it's saying that there is an NSSA normal. If I do again, if I activate the total NSSA, I should see that it starts recomputing. And once stops, we will see a key keyword, kind of redundant, but it's a key keyword that is saying do not install untranslatable default route, right? So in this case, because I'm generating the default route, you cannot install a default route coming from the ASBR inside the NSSA, because now it's becoming untranslatable. And the reason why it's becoming untranslatable is because I'm already generating a default as an ABR. Hence, I have to look for the mechanism to invalidate the advertisement. The mechanism for OSPF to translate an LSA in the NSSA is via the P bit, right? Mm-hmm. So the propagation bit. And that bit is set to 0 if the LSA cannot be translated. If the LSA can be translated, then the propagation bit is set to 1. Curiously, in this case, if you check the database, it's kind of confusing, because if you check the database, the P bit is set. You might think then, well, I should see the default route advertisement into the backbone, right? Because the P bit is set and it's coming from the ASBR, which is R3. But it's not. So you have to go into router 3 and dig deep and have to check the debug in SPF and see, well, first step is saying that it cannot translate the LSA, but it has the P bit. So how is it doing it? And the mechanism, as mentioned, is because it's invalidating the advertisement by setting the metric into the max. So that's basically how it's doing it. And the RFC 3101, I think it is, it mentions all the details and all the mechanisms. And there are the specific mechanisms for default route advertisements that the folks in your channel can see in action there listed.
Yeah, that's a good point. I should actually look up the RFC if that provides all this information. It'd be good to read that. Actually, coming back to that, I kind of want to share my topology now, just to show you that I'm not crazy, that it's really showing the maximum distance on the other route as well. So let me grab control and share my screen. So, okay, I'm gonna backtrack a little bit because, so this is part of my other topology that I'm working on. So router number is gonna be a little different, but you can see that these are also connected in a chain. So effectively, this is R1, R2, R3, and R4. So I can start with effectively R6, which is going to be R3. So let me just do show run and section router OSPF so you can see what's configured first of all. And I've used slightly different router ID actually. So, so that's what's configured, and show IP routes. So you can see that there are those two static routes as well. So let me just show the configuration on all these devices first, and then let's see what happens. So you can see that we're also running this as a totally NSSA at the moment. And then let's check this as well. There shouldn't be really anything too interesting here, but I'm going to do it anyway. So yeah. So now, okay, actually, let me go to R2. So show IP route. So you can see the default is not there as expected now. The other static route is. So if we look at the OSPF database, so show IP OSPF database, and then the NSSA external, and let's look at the default route first, and actually the internal keyword. Okay, so here we see this distance, it's set to maximum, right?
Yes.
So if I run the same command, but now on the other route, the other static route, so 8888, so you can see this is also set to the maximum. And that should not be the case, right?
Do a show IP OSPF. Yeah, it should not be the case because it should be actively using the LSA for routing. So if you do a show without the internal keyword, can you do it again?
Yes.
Yes. Yeah, so show IP route.
Yeah, so you can see that this is actually in the routing table right here.
Yeah.
And it is actually being advertised to R1 as well. Show IP route. You see right there.
Yeah, can you check the same LSA but for excuse me, the same route but for the external LSA? Show IP OSPF external, database external.
On R1 or which router?
The ABR.
The ABR, so R2, okay. So show IP OSPF database, which
external.
one? External.
And 8888.
Oops. And you want, do you want any other keywords here?
Just that. Okay, and now internal. Yeah. So the original metric is 20. And the
the distance is
forwarding address is that. Huh, that's weird. So in my outputs, it doesn't show like that. It shows differently.
Yeah, and your output makes more sense because that's why I struggled with the scenario. I'm like, I cannot figure out why the default route is not being installed and not advertised to the other routers when this one is, because the output looks very similar. Of course, I didn't remember this section from the RFC that describes the behavior when the default routes are advertised from different places. But just merely looking at the output, it didn't make sense. Why?
Yeah, it is confusing indeed. Like you cannot derive the behavior of describing the RFC with these kind of outputs. It's confusing indeed. Like what I'm having in my outputs makes more sense. Maybe it's something doesn't fit here, but with the outputs, but yeah.
Yeah, and if I show you the version, it's this one. So
this is this is even more recent release than the one that I'm using.
Yeah. Okay.
Yeah,
so that made the scenario even more confusing because my output doesn't match what it should be. So
yeah.
I can stop sharing the screen, and if you want to do another summary just to like kind of briefly put it together so we can end the recording there, because that was a lot of content that we covered there. So
yeah, just as a reminder, an ABR in an NSSA, or let's start from the very beginning. An NSSA is simply a mechanism in OSPF that we have in order to avoid injecting external routes into the specific spatial area while allowing redistribution in the internal area. A total NSSA is basically a mechanism to go even further, because instead of we don't only suppress LSA type 5 for external LSAs going into the NSSA, but we also do suppression of type 3, which is inter-area routes. So the internal routers in the NSSA will not see those routes. So the mechanism that OSPF has in order to provide reachability to those internal routers is via the generation of an inter-area default route that we can generate from the ABRs. And that's done automatically as soon as we put the non-summary keyword. So as soon as we put the non-summary keyword into the ABRs of the NSSA, those start invalidating any default advertisement coming from the ASBRs internal of the NSSA, and they start advertising those LSAs that are for default routes, right? So putting it all together, as you mentioned, we have basically the advertisement of the default route, because we have the non-summary keyword here as soon as it loads. So excuse me, in this case it's in router 2, which is the ABR. So router 2 is the ABR. Router 2 has a non-summary keyword, which is start advertising a default route that is type 3, meaning an inter-area default route. We will see that default route being advertised or being received, excuse me. Here is a summary LSA in area 1, and it should be in the routing table of OSPF, even though we don't see it here in the global routing table. If we do show IP OSPF RIP, we should see that default coming from router 2. So in this case, if you see, the default is an LSA type 3. It's a default route coming from router 2. So basically, we are actively having that default route in OSPF routing table. We are just not using that default route as OSPF in the routing table, because the static route is being overridden by the default static route in R3. And the mechanism, as I mentioned, and excuse me, so R3 is also advertising a default route on its own. As you see in the configuration, it basically has RSA area 1 and NSSA default-information-originate, and it also has a default route statically configured. This means that if I check the advertisement locally, it has a default route or a default route as an LSA type 7 being flooded into the area. Router 2, as mentioned, cannot translate this LSA. And what it does is it flags the LSA as untranslatable, as we saw in the debugs. We cannot translate this LSA, basically it says. And the reason why is because I am already originating an inter-area default route, and I am an ABR, so I'm overriding this default route advertisement coming from the NSSA. And we can see more details about that. The internal keyword in OSPF. So if we basically see the route being marked as the maximum metric, and basically the translation doesn't happen, even though we have the translation bit or the propagation bit, the P bit set to 1. So we could translate the LSA, but we are not allowed to do it based on the advertisement rules in OSPF. So I hope this has been clarifying for the folks in your channel. And thanks for inviting me.
yes, thank you for joining me. This has been great. I learned a lot of new information, and also it clarified the confusion I had in my own lab. And actually, like, just to compare, can you show again the using the same command, but for the other static route? So we see what the command output should be, because it was wrong in my topology. Yeah,
as you see, is having the routing bit set, so it's being used, actively used. And if I do the internal, I don't see the maximum metric being set, right? So this should be the output that you see.
perfect. Yeah, because mine said that the distance is also set to the maximum, which means that it shouldn't be used or it shouldn't be advertised, but yet it was in the local routing table and it was being advertised to R1 as well. So this was the disconnect with my lab environment for some reason. I don't know why.
Yeah. But indeed, you can check, I think it's RFC 3101. You can check me on that, but I think it is, and that is the RFC 87, I think. Yeah, those are the two RFCs for OSPF NSSAs, as far as I remember. So the folks in your channel can see what is the behavior with the old mechanism of NSSAs and the new mechanism of NSSA. So to be more clarifying, OSPF was defining RFC 1583, the base OSPF, right? And we have a new we have an RFC that is called 1587, which is specifically for NSSA. We also have a new OSPF, which is RFC base OSPF, which is RFC 2328. And the NSSA behavior that corresponds to that is RFC 3101 for NSSAs. So the folks in your channel can differentiate the behaviors based on these RFCs, map, the different behaviors. It has information about, which LSA is going to be chosen, the craziness of the path selection of OSPF. So yeah, hopefully that can help them as well.
Yeah, that can be a topic for another video, maybe comparing all those different versions and how the behaviors changed from different standards.
Yeah, for this specific case, they just have to check the RFC 3101, and that there should be a clear cut there.
Okay. Yeah, seems clear enough for me. I will investigate this on my own a little bit as well, and maybe try to run this in another lab environment to see if I get the output that I'm expecting. So yeah, we can end the video here. Thank you again for joining me. Thank you for your time and these wonderful explanations. And
thank you, I appreciate it.
Feel free to come back. I'd be happy to welcome you back in the future.
Thank you, Rika. Have a nice day, guys.
Thank you, Elvin. All right. And thank you for watching to everyone on the channel. I'll see you next time.